We're right to go, Nick, Larry, Mark, Jeff.
Yep.
Okie doke. Right, peoples, thanks very much for coming along tonight. And hopefully you're going to get a little bit of information out of what we've got on offer this evening. So stock water quality and quantity, what's to know is the title of our webinar tonight. Just a few little bits of housekeeping. You might see this at the top of your screen for your Teams there. This button here, if you click that, you'll get a little dialog box on the right-hand side of your screen. You can ask a question there. If you can type that out, and then we can have a look and get back to you on that. And when we get to asking some questions, or if there's a burning question at some stage, if you tag this little hand symbol, we can get back to you and unmute you for there. With questions, we'll try and hold most of those off until the end of the presentation. So take some notes on what you might want to ask. And by way of introduction, my name's Paul Simpson. I'm a Senior Land Services Officer based out of Albury in mixed farming. And we've got a few other people there tonight from Local Land Services, and also Larry Walker from Southern Scientific to talk about blue-green algae. So just a note that the video and mic will be back on for the questions and answers, and the session's being recorded for those that either can't get to it tonight or for your convenience later on to have a look over it again, plus take notes of any of the resources that we have links to in the presentation tonight. So what is this evening about? I'm just going to cover a little bit about why we're actually here. Before we get into this evening's things, I'd just like to acknowledge traditional owners of all the different lands upon which we might be living and meeting tonight, and acknowledge their elders past, present and emerging. So part of the reason why we're talking about this evening is that, as everyone is aware, except if you've had one of those 140mm rainfall dumps over the last few days on your property, dry conditions and in some places significantly diminishing water supplies. And as many landholders have mentioned to me over the last 4 to 6 weeks, the impact of evaporation losses has been significant on their water storage systems. And from that, you can lead into potential animal welfare issues. So we're going to cover off a bit about that. And maybe some of the information we cover tonight will enable you to try and avoid some water carting, or even better, if that's sort of on the horizon, you'll have some tools to work out when that might actually be happening. So I'm going to pass over now to Mark Corrigan, and I'll let Mark introduce himself. If you want to start sharing your screen, Mark, and I'll get out of it.
Oh, can you see that? Yep, all good. We're all good to go. So that's great. Hello, everybody. Thanks for coming along tonight. So I'm Mark Corrigan. I'm one of the district vets located at Albury down here at in Murray Local Land Services. And I'll just find like, all right. Yeah, so I've just put this picture up here, a empty cup with water, or imagine if there's water in it, and a very typical dam that was just recently taken at a property down here. And I've sort of, as a vet, probably didn't really think about a lot about water until recently. But I remember 20, 30 years ago, my parents had a property, and it was a property that was mainly fed by dam water, and another property that had trough water. And it was interesting. My father used to say, gee whiz, the animals do so much better on the trough water direct from a town supply than from dam water. And so it's intrigued me recently that we've understood a bit more about water and understanding. So water, it's the most basic, it's second most important nutrient after, of course, oxygen. At the cellular level, it's needed for basic cell function and digestion and temperature regulation. But as you can imagine, ruminants have got this big organ there called the rumen, and it needs lots of water and lots of good quality water to make that rumen function well and to have maximum production for those animals. And when you consider how much water an animal needs, I've just put those couple of things up, which we're a dry sheep 2 to 6 litres a day and a dry cow 35 to 80 litres a day. And that will change depending on depending on the age of the animal, whether in lactation and temperatures, very high temperatures. I could imagine that cows were drinking 140, 150 litres days if they had cows at foot. So always consider those totals and what their stage of lactation. Some work done back in the 70s by Utley demonstrated the fact is that water intake does affect feed intake. So it's unlikely this would ever occur these days, but they restricted water. As you can see, free choice, there was a feed intake of 6.2 kilograms a day. And as they restricted water, the feed intake decreases. So to get maximum production, we want to maximise feed intake, which has an opportune thing. So the water intake has been restricted, it definitely has food intake. So if we're watering stock and they're not getting the maximum amount of water they need, then that could be production. Another study that was done by Kenzie was they found that they compared stock drinking out of dam water and articulated water from a dam water compared to a domestic supply. And they actually showed that by drinking the clean water, there was 23% greater weight gain in steers that were fed drinking on the clear water. So it has a dramatic effect. So when we think about water, and these aren't exhaustive, some of the things we look at, but some of the basic water quality things we look at is we look at some basic factors. pH of water, ideally it should be around neutral, but if you get too acidic, it can draw acidosis and stomach upset. And if you've got the pH too high, it can actually cause digestive upsets. Other things you think about is water is hard water. So if they're high in minerals such as magnesium and calcium and ciliates, it can increase the risk of bladder stones and the like. So especially if we're on these concentrate diets at the moment, it's you must consider what it is with hard water. Other elements like iron can have an issue with intake. If it's too high levels of iron, that can affect your intake. Salinity is another one. I'll just show a graph, and pollutants contaminate. So salinity, here's sort of a basic table where tolerable levels of salinity. Obviously, depending on the type of animals within that group, like sheep or lactating ewes may not be able to tolerate, wethers can. Dairy cattle cannot tolerate salt water as much as, say, beef cattle because they're consuming so much water and their consumption is so high. When we think about water pollution or dirty water, as some people like to use, we consider what a factor of water. So one of the things we might think of is, as you know, cows love going into dams and pooing and shitting and things like that. Work done in the past, we looked at levels of E. coli levels or that could have an effect on water. And what they did show, if water is contaminated with feces, as that increases contamination, their ability to drink that water, so they put off that water and they don't drink as much as they should. And obviously, if you're not drinking as much water as you should, then that actually has an effect on water intakes, which in coincides has an effect on production. Other we could think about runoff is chemical runoff. So insecticide and pesticides can affect that quality of water as well. If you get a big rainfall event after some spraying or something like that. Algae, Larry will probably go a little bit more into that. But obviously it's been a common thing at the moment as dam level gets lower. We've seen algal blooms. It's actually quite common, but the actual poisoning as a veterinarian, we probably don't see it that common. But the times we do see it happen is when animals are forced to drink that water if there is algae in it and with the toxins are there. Usually animals will die within 24 hours. If they've sort of died and it's pretty close to a water source at a blue gala, you can pretty likely to like to have potentially died of blue-green algae. It's a neurotoxin, can affect stock, and I've occasionally seen a few stock in the past that have been clearly diagnosed with it. Other things we think about with dam water, quality water, especially around dam stuff, if we think about that, is potentially other bacteria, things such as E. coli, Salmonella botulism. As you can see, there's an animal that's died by the dam there, but there's a risk of the botulism. Leptospirosis, I mean, that's if you got potentially a risk, if you've got pigs and that sort of thing, they can spread leptospirosis. So dam water can be more inclined because you've got these areas where animals can less dirty water, these contaminants can be more likely to cause issues. And also, you think it might be dry and we haven't got those liver fluke, we haven't got those like liver fluke type years, but probably something that I've probably mentioned about quality water is, as you can imagine, we had that bit of a spring, and then we would have had a bit of green in the gullies that would have dried off, and lack of feed. So generally, those areas that stock are forced into those, eating those areas of where liver fluke can exist, can have a pet to pick that up. So I'd probably more mention that it's probably something to be aware of. Just because we've had such a dry year, don't assume that your liver fluke problem has disappeared and gone away, because they are pushing in those areas, and consider, and if you do think you've got liver fluke issues, consider talking to your private vet where they can do some blood tests to see of exposure, but definitely don't let that let go by the wayside. The other thing that can affect in some environmental factors that can affect the suitability of water, temperature can play a part. A study that was done back between British and Brahman and Bos Indicus breeds demonstrated that actually the Bos taurus type animals do not tolerate hot water. So you can imagine if you've got water being delivered to a trough through a pipe that sits on top of the ground and it's heating up, then it could affect the amount of intake and food efficiency. In this study, they actually found that the Brahman type cattle, it didn't actually affect them so much on food intake. So they're much more tolerable that weather, tolerable that warmer water. But definitely the Bos Indicus type animals are susceptible to that. So when you're thinking about suitable for water and what's there, you should consider some of these different age and condition of stock. So younger lambs may need a bit more water, and then older ewes especially can potentially need more water. If ewes have got lambs at foot, they might need more water than, say, dry weather. Breed differences, you've got the merinos are quite, I think British breeds don't require at least 20% more 20% more water compared to merinos. Merinos are very stoic animals and can actually concentrate and urine greater than the British breed, so they can tolerate lesser amount of water. Consider watering radiuses. There's probably looking at 2 to 2.5 k's when you think about watering points, and so they're in reasonable distance to where stock can get to, and type of watering points, you should considering some of those. And probably the last thing I was just going to touch on is, obviously the issue about animal welfare and the difficulty with dam water. Stock can get bogged in dams, so just be obviously very conscious of dams when they get low, and understand that I've had dams that looked all right, but once you walk in there a couple of metres, they're very boggy and potentially a risk for stock to bog in dams. So, I mean, hopefully I've just sort of touched on some of those things today, but I've probably got time. I'll just do a case study and this is probably thinking about the importance of testing water, understanding what's in the water, and especially depending on where that water comes from. So a case that one of my colleagues were involved in, we had 18 steers died out of 75. Of the steers, the sheep, there was no actual issues with the sheep. And the clinical signs are in hollow, flank, depressed. Most had diarrhea or dysentery in the cattle. PM lab testing had no significant finding. There's a number of different diagnoses there. Salmonellosis, clostridiosis, floodplain staggers. This was sort of west of here. Mycotoxin, blue-green algae poisoning, lead poisoning, arsenic poisoning, nitrate poisoning. And the dam water tested negative for blue-green algae. So that cleared that out. But what was found in the investigation that the dam was actually fed by bore water. It had quite a dramatically high electroconductivity of 32,000. That's pretty high, and had other minerals and high chloride, high salt levels, calcium, magnesium. So the dam was filled from the bore 18 months previously, and as that dam actually diminished in the amount of water in it, it actually concentrated it more and more. So eventually these cattle succumbed to basically, salt poisoning basically at the end of the day. It was interesting that the sheep was able to tolerate those high levels. But I think that probably the most important thing is, I suppose what we're here talking about is trying to improve your water to the best of your ability, to improve production and welfare in animals. And if you're unsure about the water quality, the important thing is to get it tested, and talk. Paul will probably talk about that a bit later, but understanding the quality of your water so you can make judgments and understand what you need to change to make that better for the stock. But good water, good production, good welfare. I think that'd be it, Paul.
No worries, Mark. That sounds great. We've got a couple of minutes if there's any quick questions for Mark, but we can always come back once we wrap things up before we move on to Larry. Kathy now. Kathy's got a question. Oh, there she is. Let's
Kathy, you should be able to unmute yourself there.
Thank you. Look, I don't know if this is a dumb question or not. I just, where I am, and we've got quite high acid soils, would that affect the quality of the dam water? Would that affect the pH levels in the dam water?
Unless anyone else, I probably would doubt very much. I don't know whether there'd be a correlation between acidic soils and acid water. I mean, I'd be probably more about, if it's just runoff water, you'd expect it would be fairly close to pH is neutral because it's just running off the ground. I think the concern is the pH is if you're bringing up bore water and understanding where that water's coming from, and that could have a bit difference in pH.
Yeah.
No worries.
Jeff,
thank you.
have you got a comment on that one? I wouldn't have thought it'd make too much difference there. If you've got country that's acid, there might be some different minerals and stuff that get into it, but I wouldn't have thought it would significantly affect the pH.
Yeah,
no, generally, acid soils, we don't see acid water in our dams. So our subsoils generally are high pH. And that's where the water is held within the dam, and it has greater influence than those acid soils.
Just going on from that, we've got fairly high aluminium as well. Would that have any impact on the water quality?
In terms of the water quality, not sure, but the Jeff or Mark, aluminium on stock?
Generally off acid soils, again, I wouldn't see a significant issue. When you think about the dilution factor of so much water coming off that landscape and the amount of aluminium you're talking about in the soil, it tends to get diluted away. It'd be unusual to have a major problem.
Yeah, and that's a pretty straightforward one with a water test, Kathy, that you can get tested as well. Larry, you had something to add there?
Thank
I
you.
was just going to say that the aluminium response would be pH dependent. So you would need to know if it was actually a strongly acidic dam or not. But from memory, aluminium is a problem below about pH 4.5. Can any of you guys confirm?
Yeah. Certainly in soil pH.
4.5.
Yeah, but so for a dam to be running that acidic would be quite extraordinary.
Yeah.
The acid sulfate soils. So, some of the wetlands on the floodplain down further south, you might get some issues, but not on farmland as such.
Yep.
Okay.
No worries. I'm going to pull us up there for this set of questions, and I'll hand over to Larry to talk a little bit more about the blue-green algae scenario. And I've got you on about 10 minutes there, Larry. So
Yep.
See how you go there, buddy.
That's okay. Can I just do a quick follow-up point for Mark, which is that I do a hell of a lot of farm bacteria work where I am in southwest Victoria, and I basically every dam, every creek, every river around here is like an open sewer. They're just in horrific shape. Like I usually do bacteria counts on a per 100 mil basis, and I'm honestly issuing reports to clients to just say there's so many I can't count the bloody things. There's well over 1 million bacteria cells per 100 mil in your water supply, and that's probably why your animals look like death on a stick. They're really getting flogged hard. But anyway, blue-green algae. Mark, can I have your slide up with the teacup? Because that was just a really nice shot of a blue-green algae dam. Can you?
Yeah, I'll do that. Yeah.
That?
Yeah, I'll get it for you. Yep.
Okay. At the moment, I've got a multi-viewer screen. I don't know if I've got to press a button.
Be right. Should be sharing now. Yeah.
Oh, there we go. Beautiful. Right. That sort of thing is just that classic straightaway question of, is it blue-green algae or not? The presentation looks about right. Usually in a phone call with someone, I'll be saying, look, does it have any leaf or root structure or any stringiness to it? Because usually any of those structural sort of contexts generally say it's not blue-green algae. Blue-green algae, the easiest way to describe it in the field like that is it looks like some clown's been sprinkling sort of green sugar in your water. It's just sort of slightly granular, slightly clumpy. Paul, can I have that jar photo up, please? Because that'll show exactly what I'm talking about. But in the meantime, when we sort of consider the view of that dam, you really need to answer the question of, is it blue-green algae or not? Yeah, so that's a sample that's come into me. That's that granular sort of aspect I was saying about. You can see it in that lower layer in the jar. The decaying layers are in that upper section. So it doesn't really have much structure to it, but there's a little bit of sort of fine clumpiness to it. I've found that if it's just a solid uniform green water, it's usually a little single cell microalgae. So you can sort of do a little bit of field guesstimate work on what it might be. All right, the blue-green algae itself, I mean, all algae, you've got to remember, are just blatant opportunists. You know, when the nitrogen level, when the phosphorus level and the temperature's all good and the sun's out, they just basically party on and consume. That's all they're there for, is to be a consumer of material in the water. So yeah, you can get many algae that just don't do anything except block your pumps or give you grief, but blue-green is a special little case. So we really need to actually take a sample and get an assessment done using a microscope. Paul, that little sort of cartoon picture thingy with the two algae types, please.
Yeah.
Because yeah, basically the sample will come to me, put it under a microscope. That's generally the two presentation aspects for Anabaena and Anacystis, which are the two main blue-green algae types. The Anabaena just looks like a classic string of pearls. It's a really strongly characteristic presentation under a microscope. Anacystis, usually see all those little green beads, and it has varying degrees of that clear, snotty sort of gear that goes with it. There's probably a much more technical term for it, but that'll do. So that's the sort of presentation. Yeah, I'm literally bunging it under a microscope and seeing what it looks like. Paul, can you just grab me that microscope shot? That's the sort of thing. That's actually a phone photo down a microscope. So you can see some of those little ring structures in there, which are classics for that Anabaena structure. And then that other gear in the background is just, it's something else. Half the time I can work out what it is. Half the time it's like, guys, it's not a blue-green algae. I don't know what it is. That actually could be spirulina. So you could scrape it out and sell it to your local health food shop type thing. Spirulina just has this gorgeous look like green spiral pasta. Anyway, all right. So we've sort of we need to get an assessment done on, do we actually have blue-green algae, or do we just have some other opportunist along for the ride? We get a confirmation we've got blue-green algae. Two approaches at this point. One is basically go, can I live without this water supply? I'm going to have to stand off, because from what Mark was saying, there is a real toxin risk. Some of these things are pumping out liver-specific hepatotoxins, so you don't really want to play around and sort of see what the toxin is. I'm running a service laboratory here. I didn't do that on the intro, but so as a service lab, I find that if I was to send water samples off for determination of toxin levels, A, it'll be astoundingly expensive, and B, by the time I get data back, the dam is now a completely different entity to what it was when I took the samples. So it's really hard to sort of do that in a real-time response. But anyway, all right, so if we're saying we've got blue-green algae on board, yeah, we wait. It will just consume the nitrogen and phosphorus. It will die off. It will disappear in time. Or we go aggressive and we kill off the algae. Now, in both instances, when the algae dies, the toxin release of the cell burst is the real problem as far as I can determine. So if you spray the place out with a algicide like Cuprex or Cupricide, you're going to get that mass toxin release from bursting all the cells. You're really going to have to just hold the stock off there for a couple of weeks until that toxin level just backs off. You have to wait for it to dissipate. You'll still have to do that even if you wait for the algae to die as well. You end up with that post-death standoff and wait. And usually in that, when it dies off, it looks like someone's turned up and poured sort of blue-grey paint on the surface of your dam. It's not that sort of vibrant green anymore. It just turns into this, yeah, bluish greyish sort of scummy crap on the surface of the dam. So yeah, we have Cuprex and Cupricide. There's probably some others, but they're the main two in terms of a copper-based algicide. Or you can use copper sulfate, do it the old style with bluestone. In most cases, you've got to be a little bit careful because the toxic toxic level to algae is about 1 milligram per litre of copper, and you start rattling sheep at I think about 5 milligrams per litre. So you don't have a hell of a lot of leeway. I have had people do the classic farmer response of sort of like if a kilo is good, then 20 kilos will be excellent. And they've ended up with bright blue dams that no one can touch for the next 12 months. So a little bit of caution. There is another option. If I can share a screen with you, bear with me for a second. That one, share that. Okay. This is just a Google search page, but Foslock is a CSIRO developed product. It was then hived off into sort of private industry, but it works by, it looks like granular superphosphate. You spread it like superphosphate, and as it passes through the water, it locks down the phosphorus content as lanthanum phosphate, and that's a sort of an unbreakable material. It'll just park in the mud in the floor of the dam. Bear with me while I get back again. Stop sharing. Cool. So yeah, make sure that it is what you think it is. It's we don't really want to go scorched earth when it wasn't the correct ID in the first place. Now there was some. Sorry, how am I going for time?
You got about a minute and a half left, Larry.
Sorry. Okay. The other item to consider is, can you actually sort of tidy up your water bodies prior to algae events? So I've had people have reasonable success by using straw bale filtration on the arrival stream to their dams, where it just holds back all the feces and garbage off the landscape, or ring fencing the dam and then either allowing phalaris to grow up, or if you're not in a phalaris area, use something like POA, so that you create a plantation barrier to the dam so that the landscape flow has to actually go through that planted barrier, and it literally just scrapes the poo off and holds it all back from parking in the dam. reducing fecal loads in your dam is a good thing. Reducing nitrogen is a good thing. Reducing phosphorus is a good thing. Stopping animals from standing in the bloody water and pooing everywhere is a really excellent thing. There's a lot of behaviours that, you know, generally we can adopt when we're not in the middle of a drought. But right now, there's a whole subset of behaviours that we have to sort of say, well, we'll do that when it rains. But yeah, like I say, in for what I'm seeing around this area, blue-green algae, yes, it's a problem, but honestly, bacteria loads in waterways and dams and reticulation networks, much more immediate problem. I feel for here. Probably apply to you guys too, because your ambient temperatures are higher. Yeah, it's bacteria as a you know, an entity that grows quite happily in response to temperature. The general go-to is that if you can have a black poly tank on the hilltop at 37 degrees Celsius, the bacteria content in that tank doubles about every 30 minutes continuously. Mm-hmm. So if your dam's in poor shape, push it up to a hilltop tank for a gravity distribution point, it can really go pear-shaped from there. Cool. We have had cases in this district of E. coli sepsis over the years, which you can sort of, you know, wind the system back and go, this is a water reticulation network problem. Again, you guys might be in a different sort of structure and environment to me on these issues.
Thanks, but, Larry. We might leave
that's me done.
Cool. Thanks, man. Hold your questions for Larry to the end. He might have some interesting blue-green algae queries there. What I'd like to move on to now is just a section on, given the current conditions, and as I said before, unless you've had one of these massive downpours on your property and filled up your dams, which has probably drawn a lot of material into those dams, unfortunately. But if you're in a situation where your water is low, how do you work out how much you got? And basically before that, how do you know how much you need? Now, if you're expecting rain to continue for the next few weeks and dams fill up, well, then you might be out of the woods. But in the short term, you might have to do some assessment on how to measure your dam capacity and what your stock are going to drink. So I'm just going to kick off a PowerPoint presentation here, and we're going to get into a little bit of a quick and easy ways to determine your livestock water needs. Can people see that? Can you see that, Mark? Cool. So, a key mantra in a project we ran over the last 2.5 years or so is know your needs, which is what are your stock water requirements. Know your numbers, which is really what supply you have on hand or access to. And if you've got a gap, you'll need a plan. And that's pretty simple. Now, a couple of key documents we produced out of that project, which there'll be some links to at the back end of this, and also those QR codes there. There's a plan template, and these step through a manual way to work out what water you have and what stock water needs you have. So we're going to dive into the stock water needs first, and then look at a way to calculate what you've got on hand and measure the depth of your dams and how much water you have, and look at some of the losses. So although today's weather wouldn't suggest that it's the middle of summer, but I expect everyone can think back to about only 3 weeks ago when the temperature was nudging 50 degrees in the northwestern part of Victoria and southern New South Wales as well, and probably went way over it. So we're looking at summer water needs here, and these are sort of peak needs there, and they sort of fit in with what Mark was suggesting, that some of these dry cows and cattle will drink in excess or need in excess of that 100 litres a day, and our sheep are looking at around 10 litres per day, and obviously in winter that drops off. Now, I've put some irrigated pasture figures in here because we stretch across the northern part of the river, and there's plenty of people putting water on irrigated pastures, and obviously that reduces significantly the amount of water you're going to need. And there's a few people, I know there's some studs around the place and people who have horses, plenty of lifestyle and hobby properties with, pardon me, horses. And your average sort of horse is around that 50 litres, but I'd say in this hot weather, it's going to be a little bit more than that as well. So we know how much they're going to drink on a per day basis, but how do we convert that into knowing how much we need? So I've got an example here. We've got a mob of 1,000 ewes dry here. All the lambs in it have long gone. And fortunately, we've weaned off any calves we had on these cows, and we're classifying them as a dry cow. And we've got our 10 litres per dry ewe there, and our 100 for our beef cows. Makes the maths a bit easier. And also throw in the grey kangaroos here, not so much because everyone's got a problem with grey kangaroos, but just to remind you that there are other things that do drink out of your dams, and you might have an issue with pigs and all those sorts of things. They can add to the cumulative need for these dams. So if we do some maths there, pretty quick maths, this is just a daily total for that 1,000 mob ewes and the cattle there. That's 10,000 litres for each of those mobs. And if we look for the total period, I've just used a period of 60 days here, 2 months. Normally when we do these calculations, we do them over the whole period of summer, but we're just doing it 60 days. And if you've got a dam and you think it's getting even lower, you might just limit that to 30 days to work out the amount of water that the stock are going to need. So that's how we work out what our water needs are, and we end up with just over 1 million litres here. And if you're familiar, as many people would be, with the megalitres, if you've bought water or understand it, that's 1.2 megalitres. So remember that number, because we'll come back to that when we work out how much water we got on hand. So how do we measure the amount of water we've got? It's pretty simple maths. If you look on the back of your old textbook that you had from 30 years ago, there's probably a little equation there of how to work out the volume and the water in a vessel. So the dam's no different. So we've got the length by the width, that gives us the surface area. So in this one, we call this a square dam. So 30 by 30. And then we times by the depth, and then this thing called the batter factor, which I'll get onto. And so we got, haven't got the H on there, not the, haven't got the depth. But how to measure the depth? Well, you could send the grandkids or the kids out there and dive down and get a rough estimate, but there's a few better ways to do it. If you're a fisherman or a fisher person, you might have a sonar buoy that you can, or if you've got a big enough dam, drive around with your fish finder. But one of the gadgets that was invented by one of my AgVic colleagues, Greg Becker, is a dam deep tool. And if you've been to some of our water planning workshops over the last couple of years, you would have seen these gadgets. And we have a range of these at some of our LLS offices, or you can get in touch with me and I can organise to try and get one out to you. So this QR code on this video, talk about it, show you how it's how you use it. You basically lob it in, the sinker sinks, the float floats. You measure the distance in between the two once you pull it out, and you can work out the depth. So the depth's the trickiest one of all these equations, these parts to measure, but it's probably the most critical. So there's a gadget to help you do that. So our thanks to Greg Becker and his colleagues in AgVic. So this is where we get a little bit more into the maths, and it's pretty simple maths. So volume, as we said, length by width by depth, and the batter factor. So we've got our surface area, 900 square meters, and we work out the depth, and we get 3,600 cubic meters, which is 3,600,000 litres. So that's all pretty good. However, if we look at these diagrams over here, and as everyone knows, your dam hasn't got straight walls, although there are a few rare ones around that were built at a particular period. So we need to account for this slope that takes off the volume in here. So general 3-to-1 batter, the batter factor is 0.4. And if you're quick with your maths, you go, oh, okay, so the dam size, I get less than half of what the other dimensions would suggest. So 3,600 times 0.4, we do the maths there, and we end up with 1.44 megalitres. So this theoretical dam we've got here, if it was at maximum capacity, it'd hold that. Now, one of the things to remember is if you're assessing the capacity of your dam at the moment, there's no point measuring the maximum capacity. You want to measure what's at the water level you've got. So that's how you'd measure that. And that 30 by 30 dam there at the moment, that might be down to 20 by 20 or 15 by 15. And easy to pace that out if you know your pacings. The dimensions, width and length, probably not as critical as getting an accurate read on the depth. So that's a really quick way to look at how you would do those measurements. Circle, a little bit different. There's some equations in those two books I mentioned there, and they're available to download from that QR code site. So it's all well and good to have this water in your dam, but as everyone knows, there are losses from dams, and the key one there is evaporation. A rule of thumb, basically, if you've got a dam that's 3 metres full at the start of summer, and you're in this sort of middle section of the Murray local lands region around that Holbrook Colcan, you might expect to lose out of that 3 metres, maybe a metre of that 3 metres over the summer period. The further you go west, you can expect to lose a lot more of that water through just evaporation. That's without any stock usage and otherwise. So you've got to allow for that in your calculations. So this dam we've worked out here, evaporation, this millimetres per day, people would have heard of pan evaporation, particularly those in irrigation areas and where water storages are significant. And with that dam we're looking at there, 900 square metres at this is probably around that Holbrook Colcan area, probably about a maximum you'd get in the middle of summer. So we're looking at just around 5,000, just over 5,000 litres per day in evaporation losses. If you cast your mind back to our water needs for our stock, that's half the amount of water that mob of sheep needed in a day. So we're losing that amount of water per day just in evaporation. Another couple of things we need to allow for is seepage loss. Very conservative 1 millimetre per day. If you've got a leak in your dam and that sort of gets up to about 5 millimetres per day, you got some really serious issues there. And we've got this residual or dead water. And as Mark alluded to, welfare issues with stock. Ideally, you don't want to be pushing stock down to be sucking up those last couple of litres of water because there's all sorts of issues. So we've put in here that we're going to have some residual water left in the dam. And there's also discussion around needing some moisture left in that dam to maintain the integrity of it for when it does start to rain again. So we've got some significant losses in here that we need to take into account. So if we go back to our dam and our a couple of mobs of sheep and our cattle, our 1,400,000 or so litres, which was looking pretty good. We knock off over 300,000 in evaporation. We got seepage, and we've got residual water there. And if we're knocking off 21,000 litres a day with our sheep and our cattle, it says we've only got about 65 days water remaining in that dam. So that's a really short way and a pretty easy way to calculate on your own property. And you might have a number of dams you could add together, and that'll give you an indication of how much water you've got. And some people are so low at the moment, they've already started carting water. And this will also help you if you've got a dam and you can predict how long that's going to last. You can start to think about if you need to cart water and how you're going to set up that carted water system. And Jeff and I are going to have a chat about that very shortly. So just to mention a few resources around the dam calculations, the Farm Water Management Planning Project. That site that's housed at CSU, the Southern Drought Hub, has a massive number of resources, calculators and reference to other material, has copies of those booklets you can download and work your way through the manual calculations of all those. But those booklets actually help you get your head around drought strategy, planning water for your whole farm when you get the chance. Obviously, not the ideal time now. That time's gone. Think about it once we get back to a decent season. A really good resource from our colleagues over the border there in Victoria. A really good one is called the Summer Water Calculator. And when you have a look at this video later, or just do a quick internet search, Summer Water Calculator AgVic, comes up there, and you can feed your numbers into that, and you can get those calculated automatically there on the system, and you can put your livestock classes in as well, and it discusses and gives you some readouts on that. So that's a really handy tool. There's also local land service officers statewide, and there's some specific officers out of the Southern New South Wales Drought and Innovation Hub. One of those is with us tonight, Jeff Minchin. So if you have any queries about your drought water supplies and how you might need to assess those or water quality, these are some of the guys to talk to. Southeast, Matt Lischke, he's based out of Goulburn. Brett Littler, I think he's out of Mudgee. Is that right, Jeff? Yep. And Jeff is covering the Riverina and the Murray at the moment, and Jeff's based out of that Temora office, but has a pretty big patch to cover at the moment. And the last group I just want to mention, a lot of local farmer organisations and land care groups and networks were involved in the Farm Water Management Planning project, and those organisations have access to a lot of resources, and they're people who took part in this project really up to speed with helping people do some of those farm water dam assessments. And of course there's myself as well to contact about doing any of this farm water budgeting. So that's I might pull that up just there, folks, and we've got a couple of minutes, I think, before we jump on to this last section. Any quick questions? Oh,
There's one in the Q&A, Paul.
rightio. Good question. So there's a question, and this sort of, it's a nice segue, Jeff, into what we're talking about. If the reticulation system is going to a header tank, is it worth looking at antibacterial tank treatments to cover for bugs? That's a good question. I wouldn't know the best answer for that. Larry or Mark, I wouldn't have thought. Depends where the water's coming from, I suspect. It's coming out of a dam versus out of a bore, out of rainwater tanks. So that would be my take on that. The best way to assess that, Ant, would be to get that water tested. And as a bit of a sidebar, Murray Local Land Services, and I think Riverina as well, Jeff, have free water quality testing going at the moment. So if you trundle along to one of your local land services offices, they'll be able to, most of them, or not most of them actually, only a couple. I know Deniliquin and Albury offices have the farm water sampling kits, and if you bring a clean sample in, as in a bottle that hasn't been full of motor oil or something else, a nice clean sterilised bottle with a sample of your water in, we can help you get that away to a lab. And if there's any suspicion there might be blue-green algae, we can organise that in the testing as well. But the question before on pH, that testing is a pretty standard one to come back with pH and a few minerals and salinity levels, and lets you know what sort of quality you're looking at there. So with respect to the antibacterials in header tanks, any comments there, Mark or Jeff or Larry?
Anyone else?
You go.
Yeah,
Larry.
I was just going to say that a scenario I'm seeing a lot around here is what I was talking about with that hilltop poly tank, a dam to the tank to the trough, and you can just watch the bacteria levels just multiply up across that network. And so I often request people to send me those three as a like a sweeping audit across the property. What's the dam delivering? What's the tank delivering? And then go to the furthest trough in the network and just see how god awful the water is that comes out of the line. I'll sit there with that. Does that, oh God, I really shouldn't have bits of paper. It really bugs up the camera, doesn't it? No, it's going to work. All right. That was just to say trough cleaning. There's still guys I have come in that go, oh, what do you want to clean your troughs for? That count there, we had 190 E. coli, 400 coliforms, 300,000 other unidentified bacteria per 100 mil after he cleaned the trough. The pre-cleaning figures were 2,500 E. coli. I couldn't count the coliforms. There's just thousands of them, and over 1 million unidentified bacteria per 100 mil. So cleanliness wins. But yeah, in terms of your question on treatment, I've got a lot of clients in this area that are just chucking a couple of litres of industrial bleach in that hilltop poly tank, and they're just doing it as a daily routine. Grab your coffee in the morning in a travel cup, drive up to the hilltop tank, bang a couple of litres of industrial bleach in, like the 13% industrial bleach, not the 2% domestic. And yeah, we're seeing real measurable response, particularly feedlot type guys. They can measure the response in weight gain on chlorinated networks versus raw water networks. So it's
All right,
out there,
thanks.
it's happening.
Thanks, Larry. If there's some more questions, we'll get onto those a little bit later if we got the time. I just wanted to move on to a little bit more of the practical considerations with what's standing in front of people at the moment. And Jeff mentioned, and myself, I might get you to introduce yourself in a sec, Jeff, and also about your own family farm as well. And then we'll just run through a few questions that people might have, and I'll throw a few at you, and then we might open it up to a bit of general discussion about how people can meet their water needs. And I'll throw it over to you for an intro there, Jeff.
You know, as Paul, so yeah, Jeff mentioned, I'm based up in Temora. Have worked with state government for 20 years in an ag extension and natural resources role. I have an agronomy background. Also have our own property in the Central Riverina, just under an hour north of Wagga. And yeah, we've been through a number of droughts out there, and we've learnt lots of things over that time. And I actually started my career in extension back in the Millennium Drought in sort of the southwest slopes and tablelands area. So yeah, back then we learned a lot about water quality, sizing of dams, and how to run bores dry when it gets very dry.
Yeah. Thanks, Jeff. I think I might sort of dive into some pretty not hard questions, but some stuff that people are interested in. If you had to give a few tips around how to manage your water at the moment, if you're water's looking a little bit low and you've got stock, what are some of the things that you should be thinking about and considering around that? For example, if you've got water in a paddock but no feed, and potentially vice versa, and what are some of the others to think about?
Yeah, and that's a common scenario, that you've got water with no feed and feed with no water. Some options there really is looking at setting up some temporary troughing. So it might be a poly pipe which siphons over the back of a bank into a next paddock, or paddocks 2 or 3 over, or to another property, where you can set up a trough. It's run off a siphon. If you don't have the luxury of a fall where you can create a siphon, then it becomes a solar pump or a pressure pump, where you can move that water around the property on a temporary basis until we get some good falls of rain. Some of the other things that we see, it's interesting listening to Larry, but February is algae month. Every year, and particularly in a dry year, we get algal blooms and algal inquiries during the month of February, and it's dams are low and temperature rises, and then we start to see more and more algal blooms in stagnant water. The other one too is just around ground cover, and it's a critical piece around drought management, is trying to maintain ground cover. We get back to pretty low levels, and that last bit of feed that's sitting on the ground doesn't have a lot of quality, but what it can do is keep manure and sediment and silt out of your dam if you can leave that cover still there. And it's sure as anything with these long dry spells, the rain that breaks it is often a big heavy storm, like we saw down in Wodonga the other day, and we're seeing in the northwest corner. We see these big dumps of rain, and we end up with a lot of manure and a lot of grass and sediment, silt, and other things go into dams. Then we run into a different problem of not having enough water and our water quality being low, to having plenty of water, but our water quality is still low and unusable because of all the impurities in it.
Yeah, no, that's good. And Jeff, a simple system of your water source, a header tank down to a gravity feed to a trough is a pretty common thing, whether it's on an extensive system that you've set up in the past or an improvised system. Because I'm guessing there's no value at all in carting water and putting it in a dam.
No, and I have, to be honest, I have seen that. I definitely wouldn't recommend it. It's soul destroying, dumping trucks of water into a dam and then it just disappears into the mud. So then you have to go and get more. If you have to cart water at all by a truck, you really need to go into a tank and have a trough set up so that you're maximizing the use of that water. Better still, put it into a pipeline, into a header tank and into a trough. Possibly with a solar power pump that keeps filling that header tank all the time. Is a very common and pretty simple system.
Yep. No, that sounds great. And Jeff, I'm just mindful of time here. Are there any, when you're setting up a system in terms of piping is a very critical thing, the diameter and the loss of pressure. And is there any sort of rules of thumb that generally go along with your sheep or cattle systems that you might be setting up?
Yeah, look, we always go for high flow, particularly with cattle. So, 2-inch or 63 mil pipe. So you're getting high flow and high pressure, or high flow, and which give you plenty of pressure. For sheep systems, you can get away with 1.5-inch type pipe or 50 mil. But again, we always err towards larger pipe if we can, particularly if you've got to transfer water any distance, because the friction loss in the distance in that pipe will lower your pressure and lower your flow. So always go to a large size pipe as best you can and get an irrigation expert to actually design the system for you if it's extensive.
Yeah, no, that's great. And Jeff, one of the discussions I have often, and you hear when we're doing some containment area discussions, is about the peak flow rates. So paddock trough systems, you've obviously got a big bunch of animals that seem to crash onto the troughs. Can you just talk a little bit about peak flow rates and what that is and the implications of it in either paddock system or a containment system?
Yeah, so you really want that peak flow coming through that pipe, that when animals come to drink water, they're not actually dropping the level of the pipe, the trough at all, because if the water level drops, they'll start mobbing the trough and can be disastrous in some cases. So if you've, depending on the number of animals you're watering, we like to see up to 2 litres a second, I think it is, or up 1.5 litres at least, so that when animals are drinking and they've got all their heads around that trough, that we don't see that water level dropping, that there's enough to replenish it. You will find animals that are used to trough water, they will have a pecking order, and animal behaviour will mean that they'll just move in and drink and move away until those water levels drop. And if they see the water drop, then they can start to get a bit anxious about that.
No, that sounds good. And Jeff, what about trough size? I mean, in the paddock, it's a bit critical with your peak flow. What about containment areas, which you mentioned ground cover before, and containment area is a great way to protect that ground cover. What about trough sizes and the type, what they're made of?
Yeah, so for cattle, we always recommend concrete. For temporary systems, you can get away with poly for short periods of time, but for longer periods of time, we'd be looking at concrete for cattle. Sheep, generally, you can get away with almost anything sometimes, but a concrete or a poly trough. Obviously, concrete's going to last a lot longer. One thing that we harp on a lot is it's a lot about flow and less about volume, is that you just want plenty of flow to fill those troughs. In containment, you want that water turning over regularly so that it actually keeps the troughs cleaner, and you don't get the dust on the surface, less algal issues in those troughs, and you're constantly refilling those troughs and turning the water over. I think that stands to reason as well in a paddock system, that you don't want the trough massive, that the water's not turning over regularly. You sort of need that constant turnover. And it's mostly about flow, less about trough size.
No, that sounds great. I've just got a couple of photos, Jeff, of some reasonable trough setups and some not so reasonable trough setups, and then we might go to some questions from folks. So obviously, this trough on the right here, They've got this cage around it, and the float and everything's protected on the inside and stops the stock getting in there, and young calves as well. This gadget on the left here, this is actually a water trough. It'll measure the water rat, measures how much water's in that trough, and sends a signal probably via wireless phone network, and tells you what's going on with that if you've got troughs that are a bit remote or you need to monitor these things. And a couple of examples of things you might not want to aspire to. Obviously, this trough's been picked away, way it was set up, and a lot of stock around it over the days and the years. Obviously, this one here, great, they've got a bit of a cage on it, but obviously the float's not working, or it's actually floated away and the whole thing is just pouring out water. And this is obviously a system here where the stock have pushed it and given it a bit of grief. And I noticed there's a bit of a hot wire, a bit of a fence here, so maybe it's a dairy that is getting a hard time there. There's a couple of other things you might want to look at: getting good bedding around your trough systems so that they're not going to suffer these sort of consequences. So
putting a road-based pad down, or even some conveyor belting around underneath those troughs and around that immediate area, can help stabilize the ground. The other thing is those other troughs that are leaking there, the float in the trough is actually set too high, so the water's going over the edge. They need to be set lower so that there's a 20 mil gap or so between the top of the water and the top of the trough.
Yeah, no, that's a good point. Well, we might wrap that one up there, Jeff, and open the floor there. If Nick, you want to open up the microphones there. But there's just one of the questions in the Q&A there. Kathy's asked, what is the benefit of a header tank versus a solar pump direct to a trough? You want to take that one, Jeff?
Yep. So a header tank gives you storage in the line, so that if something goes wrong with your solar energy, so you get a cloudy day, the pump's not working and it's not pumping enough water, or there's a break in the line somewhere, or there's an issue with your solar pump, at least if you've got a header tank that might give you a day, 2 days, or even 3 days is our recommendation, you've still got water in the line, which gives you water in the trough until you can get that issue sorted out. Particularly with solar pumps, you need some storage in the line that will, if you get a cloudy day or a cloudy run of days, that you've got water in the line to keep that trough full until you get another sunny day. Not so much of an issue in the summer where we get very long days and plenty of sunlight, but in the mid-season, autumn, spring, and particularly in the winter where you get lots of cloudy days, you may not fill that tank.
Thanks, Jeff. Yeah, great idea. And I just put up a picture there, some rough design setups, and they could be a temporary or a permanent system depending how you're traveling with your water, and obviously different styles of systems there. So yeah, any more questions from anyone out there?
Paul, I see a question earlier from Maureen around appropriate water testing for river water, stock accessing river water.
Yeah, that was a good one. I saw that one. Thanks, Nick. Yeah, Maureen, as I mentioned there, Local Land Services got a free water testing going at the moment, and that's just a basic test that they do to assess suitability for livestock, and that's a pretty standard test you can get done from most sorts of labs. There's labs around the place. I know Albury Council have their lab out at West Albury. There's a lab in Benalla, and there's a few others around that will do that. And that's probably just your best way to go about it, and it'll give you a rundown on the basics. And if you do need some help to interpret that, then there's always Local Land Services officers to help you with that as well. The labs, I don't think generally, some of them will give you a sheet of, if it's a livestock test, they'll give you some levels of salinity tolerance and other elements, like Mark mentioned before with the salinity for the different stocks. So hopefully that answers your question, Maureen, but yeah, it's a pretty standard livestock testing stuff out of the river plus out of the any other system. Larry.
Do you actually have access to bacterial testing in your area, in any of those service labs?
I think we do, but they're sort of above the general cut of things. If people want to go down that level, if there's any suggestion that there might be an issue, then some of those labs do those, I think.
Right. Again, because the question was about river water, and it may again be a local thing for where I am, but the river water here is bloody awful. You know, people are pumping water to holding dams, and I'm advising them that you set up a treatment system as you exit that dam. You don't just access that extra river water.
Yeah, no, that's good. Any other questions at the moment? I've got just another one for Mark, actually. Just on the alkaline scenario there with the waters and potentially bladder stones and that, Mark, is that something that's more of a consideration for breeding stock you're going to keep on the property versus stuff you're going to turn off, or can that really develop in a short period of time and affect, say, lambs you're sending off, and will you get marked down at the processors potentially for that? Or Jeff might have a comment as well.
I mean, I think the understanding is what are they being fed? If they're on concentrates, there's potentially more issue regarding that to form bladder stones. And look, the probably biggest risk for bladder stones is actually losses and death, belly water and things like that. So things with brain, and then if you're feeding with water that's got high calcium or magnesium or those silica type minerals, then potentially those can form. I mean, other things to consider around forming of bladder stones is amount of water. There's a risk if a stock aren't getting the max amount of water and not drinking enough, then that can actually, due to lesser water being like water in their bladders, that can cause those crystals to form and eventually be called stones. Jeff might have something else to add.
And I'm guessing, Mark, that if that's in breeding stock and you're keeping them on the farm, that they've got that condition for a long period of time, that'll affect production, reproduction, and all the rest of the sort of stuff.
Usually it can be death if they get bladder stones and it goes down the urethra and it causes problems.
Yes.
So it can cause losses. Yes. So as for bladder stones cause loss of production, it's when the crystals start to lodge in the urethra, and that could cause problem, and that can cause issues.
Cool. Jeff, anything to add there?
Yeah, look, I was just going to say what you're saying there at the end, like they'd be pretty uncomfortable for the animals. It's not great for animal welfare, and production losses can be significant. So it's best to try and avoid it or do something to try and lessen the risk of it through that process.
No worries. Well, I think
locked up.
Paul's frozen, I think. We've lost him.
I think they both might be, to be honest. I know Nick's saying.
I might just jump in while everyone's locked up then. I did have a case some years ago locally. They were shedded sheep and they were being pellet fed on a very high calcium magnesium bore water supply. And it turned out that the pellet lines were a high calcium pellet line. There was like 10% limestone or something in the pellet. And they lost quite a sizable percentage with kidney stones the size of your thumb. It was bloody horrific. So that's kind of the worst case of this situation. There we go.
While Paul's gone, Mark, I've had a question from earlier in regards to water quality and quantity requirements. Over here in the west of the region, there's obviously stock at this stage on both stubbles and saltbush plantations. What are the impacts there with quality? Obviously, quantity requirements are higher.
Yeah, we'll start with dry feed. I mean, you can imagine, ruminants are pretty amazing animals. They can take that pretty dry feed we've got at the moment and turn it into muscle and meat. but definitely, yeah, salt bush, I suppose, consideration if you're on high salt water with high salinity, then potentially that could exacerbate the problem. And obviously too high salt, and they may not be consuming enough water as they should, or can't get enough of their intakes to manage that. And obviously with dry feed, you need to provide plenty of water so that can mix in their rumen in that big vat, that fermentation process, that can keep mixing it. And that's in comparison to middle of winter time when stock are on green crop and there's plenty of water and plenty of fluid, that the actually fluid requirements are a lot less. And even in the past, may drink bugger all water because they're getting enough water through the wet crop. But definitely this time of year, their consumption is going to be maximised due to trying to turn that dry feed into something that the rumen and the bugs in there can process and break that all down.
Yep, absolutely. Looks like we've definitely lost Paul, so I think we've gone a little bit over time, so we might wrap up there, I think. Thanks, Larry, Mark, and Jeff for presenting. I'm sure Paul sends his regards wherever he's gone.
I'm back, Nick. I'm
Oh,
in
he's
the
there. Are you?
I'm in the audience. I've had to jump on the phone. The computer's obviously computer's got a bit tired. So yeah, I'll leave it for you to wrap up there, Nick. But yeah, thanks everyone and all our presenters. And if we want to hang around for a couple of minutes after, that'd be great.
Thanks, everyone.
Thank you.
I'm not sure if my computer's going to be